Uh, Hello, everyone. Thank you for the invite to speak in this workshop, and thank you for VCare for wanting to know a little bit more about LifeBots and about IDMind. So just a short intro. My name is Carlos. You already know this. I'm 36 years old. I'm from Portugal. I work at IDMind. I will speak a little bit more about IDMind in a few minutes. I work there as a software developer. Also, I have I am very interested in technologies, in Lego, and also in community-driven software. I have type 1 diabetes, and in the past few years, there's been a lot of technological changes, and they are still going on, and I like to know what's the cutting edge. So in my presentation, I will tell you a little bit about IDMind, what we do, how we do it. I will tell you a little bit about the challenges that we face, the so-called calls for attention while doing integration, some of our success stories, and some of our ongoing projects. So first of all, IDMind, Portuguese small company, started in 2000. We develop custom robotic platforms for whatever our clients wish to do, either European projects or companies that want to have a guiding robot or a receptionist. So in short, we build robots. Okay, what kind of robots do? We do robots for remote inspection. So search and rescue. So for instance, the smart monitoring robot there does sewage inspection. We also have a few ones that work for oil platforms. We have logistics and services robots, so co-working, small deliveries, guiding robots, receptionists, and edutainment or social robotics. In this case, robots that are able to communicate, interact with people from any age. So how do we do these robots? Well, basically, we are dealing with systems integrations. We start with a use case. We see what kind of perception the robot requires, what kind of processing is going to be needed to process all the information from the perception part, and what kind of actuation it will be needed. Does it need to move? Does it need to dodge obstacles? Or does it just need to move a box from a place to another? So we do all this not as in VCare, because we are dealing also with integration of mechanics, of electronics, and then of software. So we have to make sure that if a robot has arms, the arms are not going to be hitting himself. When we decide what kind of wheels we're going to use, we need to know what kind of floors we're going to be facing. The same for electrical systems. We have to make sure that every device is well powered. And this is more of a problem that it might seem initially, because all components need different levels of power, and we have to make sure that everyone gets their fair share. And then the software modules, we have to make sure that they all communicate among themselves, that we can use all the data available to make good decisions. But not only we have to do the system integration inside the robot, we need to think of outside of it. So we have to make sure that it's safe for people to be around. In the case of social robotics, we have to make sure that we are able to deal with permanent obstacles like doors, elevators, or stairs. Everyone knows from Doctor Who that the Daleks could not conquer the universe because they could not climb stairs. And then we have to deal with temporary obstacles. So people passing by, maintenance material in the middle of a hallway, and stuff like that. So what we try to do is to design the system as good as we can, according to what we are being asked. So first rule, a robot does not do everything. We need very specific goals so far, because we are not going to have a robot that is able to give you coffee, deliver stuff, and orient himself in the streets, everything at the same time. So we need to have very good and well set goals from the start. Then we need to choose the processing platform, make sure that we have the ability to process all the information that the robot is gathering, pick the required sensors and actuators. So do we need more sensing around us if we are in a crowded area or if we are dealing with children? Do we need stronger motors if we are dealing with higher speeds, if we are walking, if we are moving in the road? And then we have to choose a good OS or middleware. A little bit more on that in a few slides. Then we also have to make sure that we have system safety. So if we are going to be dealing with children or elderly, we have to make sure that there's no risk for them. The robot has to be the appropriate size to make sure that it's not scary for children. So we can't have a 2-meter high robot dealing with children who are not even a meter tall. We have to make sure that it's not a very heavy robot if it's going to bump in something. So we don't want to make an elderly person fall down. We have to choose the right sensor. So some people might know that some of the lasers that we can use have safety features. You can define safety areas. And if something crosses the safety area, the robot immediately stops. And finally, we have to limit our velocity. So one of the complaints that we sometimes get is that our robots are slow. Elizabeth has complained about one of the robots that she has. Our robots are slow. Well, that's a safety feature. You don't want to be walking by a hallway and then all of a sudden a robot passes by and honking and stuff like that. So it's better it moves slowly, around a meter per second, sometimes a little bit more, sometimes a little bit less. It depends on the environment. Then we have the environment challenges that I started talking about a little bit earlier on. So is it going to be indoor or outdoor? So you can see that 6-wheel robot there. It's going to be an outdoor robot. So it's got actual wheels, so wheels that can be used in cars, because it's going to face very rugged terrain. It might be able to climb some steps, but it's not going to be a good robot to be here, for instance, in a carpet room. Again, we need to make sure if the floor is going to be plain or rugged. Sometimes preparing the wheels for a plain floor, but then you have those little heights when you cross the doors, and it's going not to work. Then doors, something as simple as moving a knob and pushing the door for a robot. If we are going to build an arm specifically for that, it's going to take a lot of time, a lot of money. It's going to be complex. It's going to fail. The easiest way would be to have automated doors, but not everywhere we can find those. The same applies for elevators. It's not going to be easy to push a button to call the elevator, push a button to choose the floor. It's better to have other kind of controllers, which most modern elevators already have, but they are usually not used. And finally, social challenges. It has been dealt with here yesterday, and today it's already been talked as well. There will always be some resistance to new items in your workplace, for instance. So staff acceptance is going to be very important. If someone thinks a robot is coming to take their jobs, they are not going to like it. If they think they're going to receive a robot that will do everything for them, and then the robot, all it does is to deliver something from point A to point B, they're going to be disappointed. They are not going to like it. So it's important to set the expectations of everyone before the robot is deployed. Then public acceptance. You have all spoken how the elderly don't face technology as well as younger people would. In our experience, even children will have the same kind of response if there's something scary about the robot. So big red eyes might not be the best solution if you're dealing with children. And then we also have all the GDPR and data collection issues that you have already all talked about. We have faced a few issues with some of our ongoing projects, and I will speak of it a little bit later. So in our case, I will speak now from the software point of view. We use ROS as a middleware. What does it mean? It means that we have a common ground for all our software modules to communicate. I think it's similar to what you used MQTT. So what it does is you have different components giving different information, and it's available for the other components that need it. So all our sensors, all our lasers will publish information in the laser scan message format. The mapping nodes will be able to read from it. It doesn't matter which kind of laser it's there, because the message will always be the same. So you can build a map. Which software builds the map doesn't matter. The planning will take the map and develop a path. There's a message for that too. So all of these will make it easier for us to, okay, this laser is out of production now. Okay, we change it. It's not going to be that hard to need to change the entire system. The same applies for teleoperation. We usually use Xbox joystick, but imagine we need something different. Sure, no problem. Just change the hardware, change the driver, but everything else stays in place. So ROS has really helped robotics to develop in the past few years, because it allows us to use the work from others. It's an open source software, middleware, and we can use and publish our own software. So some of our success stories, I'm going to pass briefly by them. There's going to be sites, and I can tell you more about it later. So Squirrel has been also an European project. The goal was to have a robot that was able to pick toys from the floor and put them in the container. I have to admit, it was a pretty scary robot, because it had an arm inside of it. The arm would be concealed, and when it was deployed to pick the toy, it would go to the toy, open a sliding door, and then you would see like this really alien arm moving outside to catch it. It fulfilled the goal that it was supposed to fulfill. It can pick up toys, it can store them. Children, however, far away. Yeah. The Monarch project was also an European project. This was probably one of our most successful ones, because it allowed us to build a platform that was used for many different things. So for this project, it was used at a cancer treatment point for children and also for adults. But in this case, it was specifically to be used with children, to play some games, to entertain them, to have something for them to have fun with while they were in that place. But that platform has been used for other projects. Namely, we have one running for several years now in our Knowledge Pavilion in Lisbon. It's been there doing a bit of a guidance at the entrance, showing children what the exhibitions are about. And children are constantly breaking him up. There's always a loose arm, the head breaks, all kinds of stuff. So when we build the robot for this end, we also have to make sure it's robust. It has to take a lot of pounding and twisting and everything. The Loop, it's a simple delivery robot. All it does is to pick up medicine from the pharmacy and take it to the clinic. This is being done in a cancer research institution, also in Lisbon, because this was previously done by one of the nurses. Every month, it does around 50 to 60 kilometers. So it has been running for the past 5 years, something like that. So while it's not this really complex system, it's really useful. The minute it has a problem, we receive an email saying, please come and fix it. It's really well integrated in the place. They use it all the time. And it's really a success story for us, because it's not just something that was done for a project, then put to the side. It's being used. The Enigma project, Artur already talked a little bit about it. It's the Xeno robot. The robot is not ours, but we did the integration of different parts of the system. So the idea was to create an autonomous system that would be able to play games with children with autism. This involved different partners from different areas, from social areas and technical areas. It had a whole bunch of different OS being used, Windows and Ubuntu. So it was a real challenge to put everything together in a platform that all you had to do was turn it on and the robot would come to life. It was somewhat successful. The main exploitation that was done on this project was a database of recordings and annotations of children with autism playing these games, not in an autonomous way, but aided by an investigator. But still, it's a very large and complex database that is now available for download. The Santander robots were guiding robots. They were at the entrance of the Santander Bank headquarters. They would bring people from the entrance to whatever cabinet they had to go to, or whatever room they had to go to. It had been working for, I think it was 7 years. Now they have been put to the side, but still 7 years running every day. Ongoing projects. I'm going to start with Elmo, since Arturo also introduced it. The idea is to have a tabletop robot that would be kind of the personification of one of your virtual coaches. So instead of having an avatar on a tablet, you'd have something that moves the head up and down, makes noises, calls for attention. But then the technological side is also to be able to make calls to the family. This was especially important during COVID. And even if you are in hospitalization, it will be helpful to have one on the bedside, for instance, to call your family, to ask for help, to remember about your medication. The idea is to be a companionship, to be able to play games. And then, well, it's something there tangible. In regards to the other projects, we have the Rovit project that is meant to create robots that are able to disinfect a room. So also a COVID project, but it's going still to be useful in the future. So we decided to build these robots. One uses UV light, the other uses nebulization. So it depends on whatever room you're going to need to disinfect. And then the Harmony project is also an European project. And the goal is to have a co-working robot in a hospital. Using AI and learning and a whole bunch of stuff that was faced with the dilemma of having data from the public. So learning has been an issue. The project is still on its initial stages, so I'm sure we will be able to move forward, to move past this. Usually IDMind doesn't deal with these kind of issues. We are more on the hardware related issues, but here the problem will still be the same. It's an integration problem. We have to make sure that the robot can do whatever task it's needed. In this case, it would be to be able to sort through vials with blood samples and stuff like that, but to be able to put them somewhere so someone or another robot brings it to a final place for analysis or whatever it's needed. Yeah, this is almost my last one, I think. Yeah, so I'm done. Thank you.
Thank you.